Welcome to the 6.6 notes. Today we're going to be talking about solving equations using logarithms. Before we jump into any of the examples with the equations, in this little bit of space up here, what I kind of want to do is give you a reminder that if you have two logs with the same base that are being added together, that's like adding exponents, which only happens if you are multiplying two expressions together. So you can multiply the insides. So x times 5 becomes 5x. And we're going to use that log property on some of the equations today, which is why I'm giving you this reminder. The other reminder is that if they are being subtracted instead of added, then you divide. Okay, so notice how these are all log 2's in all of the examples. It keeps that log 2 over here. The only difference we're making is we multiply the 5 times the x. Over here we are subtracting, so we divide x by 5. The one that is being subtracted is the one that goes to the bottom. And that's just a quick reminder of the log properties because it's been a little while since we've talked about them. Last thing is, when you are solving using logarithms, remember that you cannot take the logarithm of a negative number. If this happens, that is called an extraneous solution. And I'm going to talk about that as we go through each example. Okay, so we're basically going to solve these equations. There are three main rules to go by. Number one is if you have two separate logarithms, like example 5, and yes, I know I'm starting with example 3, then you're going to put these two together the same way that I just talked about up top, like this. Then you're going to get the logarithm by itself. So for instance, on this one, we need to get rid of that 3 first. And the third rule is convert to exponential form or cancel out some logs. It's going to be one of these two things on every problem. Step 3 is going to happen on every problem. These two are only going to happen on 7 of the problems. Okay? So let's take a look at this first one. I'm just going to kind of walk you through how I would get it started. Check to see if there's multiple logs. There's not, there's only one. So that takes you from here to here. Is there anything outside this log on this side of the equation? No. So it's already isolated. That means we're either going to convert or cancel out some logs. Canceling out means, same logs. I should stop saying something. There's not two logs. So same logs means you have like a log base 4 on this side and a log base 4 on this side. There's not that. So we're going to convert. Here's what that means. This logarithm over here on the right is trying to find the power of 4 that gives you this. So 3 is a power on 4, like this. And there is a neat little trick you can use to help you. I call it the cloud. This is your base. This is your exponent. This is the answer. And it kind of makes a little cloud if you draw that out. And it just helps you keep them in the right order. Now, 4 to the third is a number, guys. It's 64. So you just change that to 64. And basically what we did is we changed the form of the logarithm so that we could do this, which is an actual number, and now we have just a regular expression. So if you ever get stuck, try converting. That's usually where most people will forget and get a little stuck. And then I'm going to add 2 to both sides. 64 plus 2 is 66. And then we're going to divide by 3. 66 divided by 3 is 22. Boom. That one's done. Example 4 is very similar. There's only one log, so we're good on the first step, but it's not isolated. It's not isolated until I subtract the 3 from both sides. 5 minus 3 is 2. Okay, so now I'm done with that one, and I'm going to convert. There's not a log base 5 on this side, so I can't cancel out a same log. So instead I'm going to do that cloud thing. 5 to the power of 2 equals 4x minus 15. Okay, and then I'm going to go ahead and just cross this out and say that 5 squared is 25. And I'm going to add 15 to both sides to get rid of the minus 15. And divide by 4. Okay, the next two examples do start to get a little bit trickier because we actually have to do the first step. There are 2 logs, so we need to condense them. Since they are being added, you have to multiply. This is going to become log base 6 of x plus 1 times x. And you probably won't write this out every single time like I just did. The reason why I did it is because I needed to show you that you're going to distribute to both terms. So I really have log base 6 of x squared plus x equals 1. The log is now isolated and it is 1. So I'm done with these first 2 steps and I'm either going to convert or cancel out the same logs. This doesn't have another log base 6 over here, so I'm going to convert using the cloud. 6 to the power of 1 equals x squared plus x. Now, this has an x squared in it. That is the main difference between this and this. Whenever you have an x squared, that is your sign that you are going to factor. Okay, and I know that's probably not what some of you wanted to hear. What that means is I need to actually subtract this 6 to the other side so that the whole thing equals 0. And then I need to find 2 numbers to put in my parentheses. This is what factoring is. That multiplies to negative 6 and adds to 1, which is positive 3 minus 2. 3 minus 2 is 1, and 3 times negative 2 is negative 6. And then you basically want to solve each one. So if I want this one to equal 0, I would subtract the 3 to this side. 0 minus 3 is negative 3. I would add this 2 to this side, x equals 2. That should be pretty familiar from a ton of things we've done in the past. We've talked about factoring multiple times. Now, when you get multiple answers, and really I should do this up here too, so I'm going to kind of come back. If I plug 22 in, 3 times 22 minus 2 is going to be 64. That is a positive number. We are fine. If I plug in 10, 40 minus 15 is 25. That's a positive number. We are fine. It is when we take the log of a negative number that we run into an extraneous solution. If I plug in negative 3, negative 3 plus 1 is negative 2. So that means this is not actually a solution. 2 plus 1 is 3, and 2 is just 2. So this one works in both sets of parentheses. You need to check all logs to make sure you can plug this number in without getting a negative. So your only answer to this question or this problem is x equals 2. Okay. So we're crossing this one out because it makes a negative log right here and right here technically. So you do need to check both. Continuing on, I am going to make one slight difference on this one. They are set up very similarly where we need to multiply these together because they're being added. So what I'm going to do is multiply x times x and x times negative 2. That's going to make x squared minus 2x. And then I'm not going to change anything about the right side just yet. This one, you will notice, has a log on the same side, and the same type of log. Technically, they are both base 10. You don't have to write the 10s to see that, but this is where we are going to cancel out same logs. The same way you were able to cancel out the bases in 6.5, these logs cancel, and x squared minus 2x has to equal 3. Now, that's basically what I have left. I want to subtract this 3 to the other side, which basically means it switches sides and becomes negative, so that now I can factor this. Because again, if you get an x squared, you're going to have to factor. And when you're wanting to factor, you need everything on the same side. Adding this 2x to the other side doesn't help because then I've got x's on both sides. So I need two numbers in parentheses that multiply to negative 3 and add to negative 2, which is going to be negative 3 plus 1. Because negative 3 times 1 is negative 3, negative 3 plus 1 is negative 2. So just make sure those numbers work out. Cover it up. If I wanted to solve this one equal to 0, I would add the 3 to the other side. Cover it up. If I wanted to solve this one, I would subtract the 1 to the other side. And then I need to make sure that these work. So I can do the log of 3. That's fine. 3 minus 2 is 1. I can do the log of 1. That one's perfectly fine. I cannot do the log of negative 1 or the log of negative 1 minus 2. So this one does not work. These are extraneous solutions because you are not allowed to take the log of a negative number. All right, moving on to example 7. Even though, and I'm going to add the parentheses here for you. Even though there's not parentheses, you still can multiply these two together because they are being added and they have the same base. So x times x and x times negative 3 is going to turn into x squared minus 3x. This one is slightly tricky because there's not another log over here, so you have to do this cloud. But when you go to draw your cloud, there's this piece missing right here. That's a 10. Remember that this is the common logarithm, and it always has a 10 if there's no number down there. So really we have 10 to the first power equals x squared minus 3x. Well, 10 to the first power is 10. I'm not going to write the little 1. I don't need it. And then this has an x squared, so I need to factor, which means I need to minus this 10 over to here. So that it's all on the same side. I need two numbers that multiply to negative 10 and add to negative 3. Negative 5 plus 2. And then my two answers are going to be, add the 5 over, x equals 5, subtract the 2 over, x equals negative 2. And we have to go check and make sure both of these work. 5 minus 3 is 2. I can do log 2, and I can do log 5. That's not anything negative, so it's fine. Negative 2 minus 3 is negative 5. Doesn't work. And then we have one last example which has some division because these logs are being subtracted. So when I go to put them together, I have to divide the first one by the second one. And this looks a little funky at first. Before you completely freak out, let me just tell you, I actually think that example 8 is easier than any of these last 3. So we now have the same log on both sides. That's fine, we cross them off. And we have 5x minus 4 equals over x plus 2 equals 3. Now, here's my question for you before we get back into this. Let me come all the way down here and say something else. If we had a problem like this, how would we get x by itself? Well, x is divided by 3, so we would multiply by 3 on both sides. And voila, these 3's cancel and we get x equals 6. Same thing happens here, it just looks a little more complicated. I need to multiply by x plus 2 on both sides so that this one and this one cancel. And I get 5x minus 4 equals 3x plus 6. And you are now back to a regular equation. So just take this and multiply it to the other side, basically. Okay, I'm going to do 2 steps at once. I'm going to subtract that 3x to this side. That's going to give me 2x. And I want this to move to the other side, so I'm going to add 4. Six plus 4 is 10. Divide by 2. X equals 5.